So concentration is a way to measure how much of the solute is on a solution. So when we see, first of all, let's see, the concentration is usually with those brackets like this. So when we are saying the concentration of salt, inside those square brackets, we say salt. When we are saying the concentration of sugar, then we say sugar, the concentration of sugar. And the units that the concentration of the solution is measured, units, are grams per liter. Per liter. So it is telling us how much, how many, what is the amount of solute, what is the amount of solute dissolved, I think it's with double S, in the solvent. So if we have something, anything, if we have, let's say that we have salt, and then we are saying that the concentration of salt is 7.8 grams per liter, that means that the meaning of it is that in 1 liter, usually water, of water, there are 7.8 grams of salt dissolved on it. Okay? If this number that you see here that is describing the concentration, if this number is higher than that, what that means is that you are having more of the solute into the solvent. So if you have two solutions, let's suppose solution 1 with a concentration of anything, whatever you may think of, concentration of 8.2 grams per liter, and solution 2 that is with a concentration of 15.3 grams per liter, then you will draw the conclusion that solution 2 is more concentrated than solution 1, because you see that in solution 1 you have only 8.2 grams in 1 liter, versus in solution 2 you have 15.3 grams of whatever is the solute in 1 liter. So you have more of whatever, salts, acid, base, whatever, in solution 2 than what you have in solution 1. So the expression that we use on this case and the conclusion that we draw on this case is that solution 2 is more concentrated than solution 1. Okay? The idea that we are dissolving a solute into a solvent brings us into another question. What if the solute is not dissolvable? Then this tells us that we have to consider that a quality of the solute, that is solubility. Solubility. There are two types of compounds. One that are able to be dissolved into solvent, and the other one that are not. So when they are able to be dissolved into a solvent, then they are called soluble. And when they are not able to be dissolved into solvent, they are called insoluble. Okay, so solubility depends on several factors. The main factor is temperature, depends on temperature. Example, if you have a glass of water that is close to 0 degrees, close to being ice, and a glass of water that is boiling, and then you put 1 cup or 1 spoon of salt or sugar, then you will see that the sugar will be dissolved faster into the glass of water that is close to boiling, versus then the glass of water that is close to being ice, close to 0 degrees. So temperature plays a huge factor into the solubility of a substance. Another factor is the mechanical mixture. Depends on mixturing it. I don't know if mixturing is a word, but mixing it. Okay, so you probably know, and you have experienced this in every day, that as soon as you are putting salt or sugar into a glass of water, then what do is you stir it. The stirring, mixing, what it does is that allows the molecules of solute to be dissolved into the solvent faster than if you are leaving that glass of water at the same temperature, room temperature, let's say, and then you are putting 1 scoop of sugar. Eventually, that sugar will be dissolved. However, will take a long time to be fully dissolved, versus if you are mixing it, then you are speeding up the mixing, making it a solution. Okay, so the two main factors of solubility are temperature and mixing, stirring, mechanically mixing it. Those will happen, those will affect only when we have a soluble substance. If we have an insoluble substance so that we are mixing, it doesn't matter what you are doing. Temperature affects a bit, but not mechanical mixing. It doesn't affect at all. An example of insoluble substance is oil. You put oil into water, they will never mix. They will create some bubbling, but then at the end, water will come up at the surface. Oil will come up at the surface, and water will stay at the bottom. And this is why spilling water into the environment, it's not a good thing to do, because then spilling oil into the environment will cause bacteria to die, because they cannot go up and take oxygen, and water to be not healthy and not good to drink. Is it okay, guys?